this video, we will examine how students can use ClassWiz to support their understanding of the sine and cosine functions in trigonometry. With your ClassWiz turned on, we'll set it up. We'll start using calculate mode in this video, so choose this mode with menu and then number 1. And for now, we'll set the angle unit to be degrees using setup. So tap shift and setup, and you can see number 2 is where we choose an angle unit. There's a choice between degrees and radians and gradians. We'll choose number 1 for degrees. And notice when we've done that, in the screen there's a little D up here to indicate that choice, so you always know what has been chosen. Now, to evaluate the sine or the cosine of an angle, students need to just tap the relevant key and then the angle size as they would normally write it. So for instance, the sine of 34 degrees, don't need to say degrees, the calculator assumes we're using degrees because of how we set it up, is given as a decimal to many decimal places. Most examples will give you an irrational number. Some results are exact, but not too many. So for example, the sine of 45 degrees is shown as the square root of 2 over 2. It's an exact number. You can get a decimal, of course, with the S to D key, but it's better to have an exact number. And even some other less common angles, cosine of 15 degrees, for instance, is also an exact number. If an angle is measured in parts of a degree, you can use decimals, but it is often better to use degrees and minutes and seconds, using the degrees and minutes and seconds key. So for example, if we wanted to find the cosine of the angle 34 degrees and 30 minutes and no seconds, notice every time I'm tapping this key here, I'm getting the same degree symbol showing on the screen, but it means degrees and minutes and seconds. And there we have the cosine of 34 degrees, 30 minutes and 0 seconds. We could put in cosine of 34.5 degrees and get the same result. But many times we would prefer to use degrees and minutes and seconds. The same key can be used to convert a decimal angle measure into degrees and minutes and seconds. So for example, 124.4, and let's put that in as a decimal, shift and equals. If we'd like to see this number as an angle in degrees and minutes and seconds, we simply need to tap this key and it'll turn into 124 degrees, 24 minutes and no seconds. Or we can tap that number again to revert to a decimal degree. This can be very useful when we find the inverses of sines and cosines. So for example, to find the inverse of the sine of 0.7, we tap shift and sine. You can see the inverse sine symbol there. 0.7 is telling us what angle has a sine of 0.7. And if we tap equals, we get a decimal angle, but we can tap degrees, minutes and seconds and get the angle in a more appropriate format. The ClassWiz gives only one result for the inverse function. So it gives only one angle with a sine of 0.7. If you wanted the supplementary angle, we would have to subtract this angle from 180 degrees. And to do that, we could say 180 degrees subtract the previous answer. That's the previous answer we just got. Use the key down here for answer, and we can see there's another angle here, and we'll put it in degrees and minutes and seconds, which also has a sine of 0.7. And we could check that that's in fact the case to reassure ourselves by finding the sine of that angle. And indeed, we see that it's 7/10 or 0.7. So the ClassWiz handles nicely finding the values of sine and cosine for individual cases. But to study the functions it's better to look at not individual values, but a table of some kind. So let's turn our classwares into table mode with menu and number 9. Goes directly to table mode. And we can learn a lot by generating and studying a table of values to understand how these functions work and how they are related to each other. So let's start by looking at the sine function. So we'll enter the sine function here, and of course we'll have the sine of x. Remember that in a table, x is always the variable. And we won't have a second function for the moment, but we'll think about the angles in the first quadrant. So the angle sizes go from 0 degrees to 90 degrees. We need a step of some kind, and remember that only 30 values are permitted in the table, so a step of 1 would be too small. A good choice might be a step of 5, every 5 degrees, and that will give us ample values to understand how the function is changing. So tap equals to see the function, and here we can see by scrolling how do these values change. So they get larger from 0, the sine of 0 is 0, as x gets larger the sine gets larger, but not in a very uniform way. So you can see that sine of 30 is halfway up to the value, the maximum value, which is at 90. The sine of 90 is 1. The sine of 30 is not halfway between 0 and 90 degrees, but it's halfway between 0 and 1. And similarly, the sine of 75 degrees, which is 3/4 of the way, is actually almost the same as 1. So if we look at the sine function using tables, we can see some of the properties apart from the one we just noticed there. So let's change the table again and choose values between 0 and 180 degrees, which will allow us to see some of the symmetries. So, and a good choice this time would be maybe every 10 degrees. And when we draw the table, we can see that some of the values are the same. So when go down here, we can see the values are repeated after 90 degrees. The values here, 0.17, 0.34, are the same values that we would see up here, 0.17, 0.34. And we can study these symmetries even better if we looked at the function, the sine function and its supplement at the same time. So let's see how to do that. Here's the sine function, and tap equals, and we'll get the sine of the supplement, 180 degrees subtract x. So we can see those similarities. Now we're drawing tables for two different functions at the same time. Let's have a look at the table, and we can see that they're exactly the same. The values are the same. And indeed, if we change some values, go over here, change the 70 and make it, say, 73. The sine of 73 degrees is there, the sine of 107 degrees is there, and they're the same. And likewise, if we made this 147, the sine of 147 degrees is 0.54, and the sine of 180 degrees, subtract that, is the same. Of course, the values in these tables can be used to draw a suitable graph to show the sine function. And to draw a graph over a domain from, say, 0 to 360 degrees, let's go back here and say 0 to 360 degrees. You need to choose carefully the step so that the table isn't, table parameters are not exceeded, and a good choice would be 15 in this case. Every 15 degrees we can evaluate the function. And here you can see the function changing as x goes from 0 degrees up to 90 to 180 to 240 to 360, and then back to the start again. And what students can see is some of the periodic nature of the sine function. They can see the values here going up to 1, going down to 0, being negative, going down to -1, and then going up to 0 again. And to see the periodic function, let's think of a value that's, say, 360 degrees more than, let's go down a bit here, say 75, there's the value of the function. If we had 360 degrees more than that, 435, it's the same value as it was before. Similar explorations to these can of course be undertaken with the cosine function instead of the sine function. But let's look now at some relationships between the sine and the cosine functions. So we'll clear here, we've already got the sine function, and instead of this function, I'm going to clear that function and we'll enter the cosine function, cos of x. And a relationship that's easy for students to observe concerns the two functions in the first quadrant. So we'll put the first quadrant values in here, 0 to 90 degrees, and as we did before, we'll choose a 5-degree step. And when the values are generated, sine in the first column and cosine in the second column, students should be able to see a fairly clear pattern, that the values are the same in each column, except that they have been in some sense reversed. So for example, let's go change our 15 for instance. The sine of 15 is 0.2558. If we change it to 75, we can see that the cosine of 75 is 0.2588. Or if we change this one to 23, we can see that the sine is 0.3907, and if we change the value to 67, we can see that the cosine is the same as that sine value. So students can play with the table in those ways and scroll the table to see how the relationships between sine and cosine are connected. But a more powerful way is to change the function here, and instead of having the cosine function, we'll put the cosine of 90 subtract x. And now when we draw the same table, we see the values are the same in each column. So the sine of 20 degrees is the cosine of 90 subtract 20 degrees. So these suggest that the sine of an angle is the cosine of its complement. And we could test this even further by changing the functions again. So make the first one the sine of 90 subtract x, and make the second one just the cosine of x, and draw the table, and again we see the values are the same. So students can see the relationship, explore it in the tables, explore it by changing values, and understand how it works. The complementary relationship works, of course, for angles that are not in the first quadrant. So if we change the values not just from 0 to 90, but say from 0 to 180, and change our step so that we get the values in correctly, and look at the values again, we can see once again they are the same. So the relationship doesn't just hold in the first quadrant. And similarly, of course, we could change to look at the entire 360 degrees, 0 to 360 and 15. And again, we find everywhere, even when the values become negative, they're still the same. Of course, this is not a proof, and students should study unit circles as well as tables, but the class whiz provides them with good insight into what the relationships are. Another kind of relationship involves looking at the sine and the cosine function together. What happens when the sine of an angle is divided by the cosine of the same angle? So let's move back to calculate mode to have a first look at that. Think of an example like single angle sine of 64 degrees divided by the cosine of 64 degrees. And if you think about that, students think about that, they should think the cosine of 64 is less than 1. So if you divide something by a number less than 1, it should increase, as indeed it does. So the result is larger than 1, which is larger than the values of a sine could possibly be. But to study this better, let's look at a table of values. So I'll go back to menu and number 9. We'll put our values of the sine function in and the values of this ratio, the ratio of the sine of x divided by the cosine of x. And I notice I've left a little thing missing up there. Okay. And let's look in firstly at the first quadrant between 0 and 90 degrees in steps of 5 degrees. And we can see here each time that the sine is, it looks as if they're the same here, but the sine is a little bit less than the ratio here. It's a little bit less than the ratio here. It's quite a lot less than the ratio there. And here, as the value of the angle gets larger, the sine of 60 is 0.866, and the ratio, the sine of the cosine, is twice as large as that, and so on. You can see the values in this column are increasing, where these are increasing much more slowly. So the ratio changes as the values change. And if we look at a larger range, say between 0 and 180 degrees, every 10, we can see the same thing happening. When we get up to 90 degrees, the value is 0. You cannot divide by 0. The cosine of 90 degrees is 0. And now the values are negative for the ratio because at this point the values of the cosine are negative. Of course, students can begin to see, hopefully, that the ratio is the same as the tangent function. It's a special ratio. It has a special name. It looks like this. And we'll leave that one as it is. And we can see these two values are the same in each of the two columns, the tangent function and the sine divided by the cosine function. Some of the properties of the tangent function are evident. The fact that you cannot have a tangent of 90 degrees, it's an undefined value. The values get negative in the second quadrant and 0 again. And again, we can study further the range of values for tangent by changing the values again, say make the entire unit circle, make this 15 degrees, say. And what students will notice, perhaps to some surprise, remember in this first column is the tangent function. You can see it goes up to 1, to 0, to an undefined value, back down to -1, 0, positive values, 0 again, and so on. So they can see how tangent changes as the angle changes. When both sine and cosine are positive, the tangent is positive. When sine and cosine are both negative, the tangent is also positive. Okay, so we can study all of the functions in these kinds of ways. Now let's go back and look at another aspect of sines and cosines using circular functions. So we don't measure angles in degrees. As students become older and more sophisticated, the more common measure is to measure angles in radians. So we'll move back to the calculate mode and see how we do that. Firstly, we need to change the setting from degrees to radians. So tap Shift and Setup and go to number 2, which is the angle unit, and we're going to choose radians in this case. Notice up here that the display shows R for radians. Now the class whiz assumes that angles are measured in radians. So if we put in an angle like the sine of pi over 2, pi is down the bottom of the screen, and 2, move out of the bracket, out of the fraction. Sine of pi over 2, which is the same as the equivalent of 90 degrees, then the result will be 1, where previously the sine of pi over 2, if the angle was measured in degrees, would certainly not have been 1. We can turn angles from degrees to radians in this mode notice that 90 degrees is, to turn it into radians, we have to firstly represent the angle in degrees. Tap Option and choose the angle unit of degrees. So now, rather than using radians, we've said we've got an angle that's 90 degrees, and the calculator will recognise the angle as being pi over 2 or half a pi radians. Similarly, if we find the inverse sine of an angle, like the inverse sine of, let's say, inverse sine of the square root of 2 over 2. It's a complex expression that we can calculate on ClassWiz. Then the result will come up as radians, because the ClassWiz has been set to radians, and the angle concerned this time is pi over 4. So we can use those measures and of course study the same properties as we did for sines and cosines, using radians rather than using degrees. To do that, if you tap to menu and number 9 to draw a table of values, we can look at the properties we looked at before, the sine of an angle, and to look at the cosine of the complement of the angle. Rather than 90 degrees, we now need to be careful to include the value in radians, which is pi over 2, subtract x. So this is the same relationship that we saw before, but with different values. We'll choose different values for the variable, because now we have radians, maybe from 0 to 2 pi. And notice the ClassWiz turns 2 pi into a numerical value, and we'll choose a ratio like pi over 12 as the unit, pi divided by 12, and again it turns it into a decimal degree. So now we're working in radians, but we can study the same relationships that we studied before. And you can see, although we now have radians, the relationship that the sine of an angle is the cosine of its complement is still the case. So all of the properties that we study for using degrees can also be studied using radians. Okay, when radians are used, other properties of sines and cosines can also be explored. For example, the value of the variable is very close to, when the value of the variable is very small, the sine is very close to the variable itself. Let's look at that particular property. So we'll look at the sine of a function, and also look at, we don't even need that value at all, so we'll clear that off and look for very small values of the variable, say between 0 and say 0.1, very small values for x, and change the values maybe in every steps of 0.01. And we can see here the value of sine is very close to the value of the variable. 0.03 for x, 0.0299 for the sine, 0.04 for x, 0.0399 for the sine. So we can even change some values manually, make a very small value here like 0.001, and see there's the value for the x, and the value for the sine of x is very close to that, although it might be hard for students to see that with the exponential notation. So we could also study in the same way the relationship between sine x and x. And when students study the calculus a bit later on, they might study such a relationship. So let's clear that and put in the relationship between the sine of x and x itself, as x has a very small value. And if these two have similar values, when x is a very small number, you'd expect that the ratio is very close to 1. So let's have a look at some small values. Maybe between, these will do to start with, between 0 and 0.1. And here you can see, of course, the first one you can't divide by 0, but for the others, the sine of x over x is very close to 1 here and here and here. As you get closer to 0, it gets closer to 1. And if we chose a really small value here, like this one, there's the value for x, and there's the value for sine x. You can see they are very, very close to each other. And if we took an even smaller value, like so, the class whiz gives the impression that the ratio is in fact 1. It's close enough for all practical purposes to be 1. So students can explore many relationships between sine and cosine using both angles and using radians, and the class whiz is providing them with a means of doing that. So that's the end of our brief exploration here for sines and cosines. As you can see, Class Whiz offers a variety of ways for students to explore these productively. You'll find Module 5 of the Class Whiz book also contains information on how Class Whiz can be used to deal with various aspects of trigonometry, including the sine and the cosine functions, as well as detailed explanatory text which can be copied for students as well as teachers. The module includes some exercises to check the efficient Class Whiz use, some examples of activities to suggest educationally valuable things to do, and some guidance for teachers. You can download this book freely from the Casio Worldwide Education website. Happy calculating!